Welcome to the first video of Math at Berkeley. In this series, what we're going to do is that we're going to look at some of the questions that Berkeley gives students in their classes. Right now, I'm taking Math 53, which is multivariable calculus, and so for our first homework assignment, we're supposed to graph some parametric equations, like so. We have these equations, in this case x equals 1 minus t squared, and y equals 2t minus t squared, and we want to graph it from t equals -1 to 2. What we do in this case is space out this interval so that we can graph different points from -1 to 2. I spaced each t by 1 in this case, and so in -1 we get 0, -3. We just plug in -1 into these equations over here. We do the same for 0, 1, and 2, and so we get these 4 points. Then we graph these 4 points, and then as you can see over here, there are these arrows, and what these arrows indicate is where the curve actually moves. It doesn't move like this because at t equals -1 it starts from here. At t equals 0 it starts over here. Then t equals 1 it goes to here, and then t equals 2 goes to here. So it goes in this direction, not this direction. And that's the thing about parametrics. In this case, you can actually say where the curves are going, what direction the curves are. Now let's go through the actual thought process behind one of the questions. I'm skipping number 4 to go to number 5 because number 5 actually has 2 parts to the question, and therefore it would be a lot more interesting to go over this one than number 4. So we have these two equations, x equals 2t minus 1 and y equals 1/2 times t plus 1. So in part A, we do exactly what we did for the first 3 questions, which is to graph what the curve would look like, and to indicate with an arrow the direction in which the curve is going. So as we can see over here, we have a t over here and a t over here. So it won't be a curve like this, but rather just a linear equation. And we can see that by plotting some points. So we have a table over here with t, x, and y. I wanted to put -1, 0, and 1 just as arbitrary points that we can graph, and I made a small graph over here as well. So if we plug in -1 into the x equation, we get -2 minus 1, which is -3. And to y, we get -1/2 plus 1, which is 1/2. Let's plug in 0 into both of these equations. We get -1 for the x and 1 for the y. And then for 1, we get, if we plug in 1 into these equations, we get 1 for x and 3/2 for y. So let's plug these into this graph right here. -3 and 1/2 would be around here. -1 and 1 would be around here. And 1, 3/2 would be around here. As you can see, it's not the prettiest graph in the world, but it is a linear graph over here. So we can connect the points with a straight line like so. We can also indicate arrows over here because the curve does go in this direction. Because at t equals -1, it was over here, and at t equals 1, it ended up over here. So this direction. And I've also named the points over here. -3, 1/2 is over here, -1, 1 is over here, and 1, 3/2 is over here. So you might not be fully convinced that this is still a straight line. After all, we just graphed 3 points. Who knows, maybe it can curve somewhere over here. Well, actually, we can prove that this line is a straight line and it isn't a curve in any way. And the way that we can do that is, well, in part B, it asks us to eliminate the parameter, in this case the variable t, to find a Cartesian equation of the curve. Cartesian equation just meaning an equation with x and y only. Now how can we do that? Just by simple elimination. Let's set t equal to itself with this x equation right here. So first we have this x equals 2t minus 1. Setting t by itself gives us t equals x divided by 2 plus 1/2. So we have that, and now what do? Well, we can plug in x divided by 2 plus 1/2 into this t over here. So we have y equals 1/2 times normally t, but we have a value for t right here, which is x divided by 2 plus 1/2, and then plus 1 over here. So now, make sure my camera focuses, we can just simplify this to get y equals x divided by 4, and in this case plus 1/4 plus 1, which is plus 5 divided by 4. So we now have a Cartesian equation for the line. And as you can see, it's just a line in the form y equals mx plus b, which is a straight line equation. So at no point will this line over here become curvy over here or over here. It will be straight no matter what value of t we put in this equation, or what values of x or y we put in this equation. And we are done.